Hello again, as you know, I'm Eli the Computer Guy over here for EliTheComputerGuy.com and EverymanIT.com. Today's class is Introduction to Virtualization. So today we are going to go over the key concepts you have to understand if you want to implement virtualization within your environment. So many different vendors have many different virtualization products out there, and this class is going to give you the overall concepts that you have to understand for you to decide what products you're going to pick and how you're going to deploy them. Virtualization overall is not a very complicated subject, but it has some very specific things that you have to understand, especially if you're going to deploy into enterprise environments. This class, we're going to go over the basic terms that you have to understand for virtualization and give you the overall ideas about how you deploy this in the real world, things that you have to think about, etc. So this class is Introduction to Virtualization, and if you give me a second, we will dive right in. So first, let's talk about what virtualization is. Now you will hear of two terms used synonymously, as in to mean the same thing, when in fact they don't actually mean the same thing. You will hear virtualization and cloud computing used basically interchangeably as the same terms. It's very important for you to understand these are not the same terms. Virtualization is a component within cloud computing. Cloud computing is something that is much larger than simply virtualization. So basically, in virtualization, what you are doing is you are separating the operating system from the underlying hardware. In cloud computing, you are separating the application from the underlying hardware. So virtualization can be a component within cloud computing, but cloud computing is much larger than virtualization itself. We have a class on Introduction to Cloud Computing, so if you're confused about this, please go view that class and it will make more sense. I just want you to understand here that virtualization is a component of cloud computing. It is not cloud computing itself. So when we talk about virtualization, what we are talking about is we are talking about separating the operating system from the hardware. So back in the old days, back 4 years ago, when you installed an operating system, that operating system became inextricably connected to the hardware that it was installed on. So if you installed Windows 2008 Server onto a piece of hardware, it was installed on that physical hardware, on that physical server. If you pulled out the hard drive from that physical server, put it into a different physical server, oh my golly, it was a god-awful mess. Basically, with device drivers and other things, when you installed the operating system, it became linked to that hardware. And like I say, you couldn't just pull the operating system off that computer and put it onto another piece of hardware. It was all bad. You could do a migration, but it was long and hard and tedious and annoying, etc. What virtualization does is it gives you a layer on the hardware that you can then install what is called an instance of an operating system. So back in the old days, you would install the operating system directly onto the hardware. Now you install something called a hypervisor onto the hardware, and then you install the operating system onto that hypervisor. That operating system then becomes what's called an instance of an operating system. So back in the old days, you would have one server here, and you would have, let's say, Windows operating system. Windows. And so Windows was installed onto the server. You then install whatever applications you want onto the Windows server that you installed on the hardware. The issue with this is if the power supply on this physical server died, Windows died. If the CPU died, Windows died. If the RAM went bad, Windows died. And it was very hard to fix the problem. You would have to fix this physical server. Sometimes you couldn't find the hardware. Sometimes you'd have to get the hardware shipped in from God knows where. And it was really bad. Well, now what happens with virtualization is you have the physical server like we had before, Then you put what's called a hypervisor layer installed on this physical server, and then you install instances of operating systems onto the hypervisor. So now your operating system is tied to the hypervisor. It is no longer tied to the physical hardware. Now, why is this important? I mean, it's another layer. It looks like it's just another bit of complication. Well, why this is important is because if you go over to another physical server over here, you install the same type of hypervisor on that server, you can then move an instance of one of these operating systems over to that hypervisor as easily as moving over a file or a picture or a document when you're using a normal desktop computer. So now your operating system is connected to the hypervisor. All you have to do is you have to have that same hypervisor installed on a different computer, and you can literally move that entire server, that entire operating system instance over to that other physical piece of equipment lickety-split. Like really, it can be instantaneous. But the most important part to understand is that you can do this now very, very, very easily because the operating system is now no longer tied to the physical hardware. It is now installed onto the hypervisor. That is one of the premier reasons why virtualization is very important. The next part that makes it very important is because you can now install multiple different instances of operating systems onto one piece of physical server hardware. So you have one server, you have one computer. You install a hypervisor onto it. Now you can install different operating systems on it. So you can have one physical server, you install the hypervisor, then let's say you install an instance of Windows 2008 Server, and then you install an instance of Linux, Ubuntu, then you install an instance of Unix. All of these different instances of operating systems can be running on the exact same server. So instead of buying 10 low-cost, low-quality servers for all these different operating systems to run on, you can purchase one very high-power server and have instances of those operating systems run on. Once you get into the enterprise world, this makes a lot of difference. Remember, if you're new to the computer world, you may be thinking, it's really cool to have 10 computers or 20 computers. Well, once you start dealing with businesses where they may have 100, 200, 1,000 servers, it's really nice to be able to do what is called consolidate those servers onto individual boxes. So now instead of having 50 servers spread over 50 physical computers, you can now have 50 instances of servers installed on one physical box. These are the reasons why virtualization is important. We're going to talk about a little more, flesh this out, but these are the two big things. With virtualization, you separate the operating system from the physical hardware that is underneath. This means you can now move operating systems the same way you can move a file or a picture or a movie document. You can now just simply move it from one physical box to another physical box. The next big thing is that you can now run multiple instances of operating systems on one physical box. So what's very popular now, if you have a Mac computer, if you like with me, I'll show you in a second, but I have a MacBook Air. Every once in a while, I need to be able to use Windows programs on that MacBook Air. Well, I cannot install Windows programs onto a Mac. It just doesn't work. You can't install Windows programs onto a Mac. So I installed something called VirtualBox, which is a hypervisor, onto the Mac. I then install Windows XP into that hypervisor, and now if I need to use a Windows piece of software, I can simply open up a Windows operating system inside the Mac computer and use Windows. That's one of the things that you can do with virtualization. Now, when we're talking about virtualization and we're talking about hypervisors, we are generally talking about two different types of hypervisors. It is called Type 1 hypervisor and Type 2 hypervisor. The Type 1 hypervisor is a native or bare metal hypervisor. So with this type of hypervisor, you have a computer, then you install directly onto that computer the hypervisor. So there's no underlying operating system. You have a blank computer, you install the hypervisor, and then you install the instances of the operating system onto that hypervisor. In type 2, or hosted hypervisor, you have an operating system underneath. So this is probably something that you may be used to by now. So with a type 2 hypervisor, you have a computer, then you either install, Mac OS X or Linux or Windows 7. You install an operating system onto the computer. Then onto that operating system, you install a hypervisor, either VirtualBox or Virtual PC or a VMware Fusion, something like that. But that gets installed onto the operating system. And then the new operating system, the instance of whatever operating system you want to use, then gets installed into the hypervisor that's installed on the operating system. Do you understand how that works? We'll talk about it a little more in a few minutes. So this is the basic overview of what you have to understand with virtualization. First thing to remember, again, virtualization is a component of cloud computing. It is not cloud computing. Cloud computing is something much bigger than virtualization. Virtualization is simply a component within it. With virtualization, you are separating the operating system from the underlying hardware. So this means you can simply drag and drop an entire operating system between different pieces of physical hardware. Believe me, if you've been doing this for 10 years or longer like I have, this is a beautiful thing. Beyond that, you can consolidate servers. So if you have different types of servers running on your network, you can now install different instances of servers on the same hardware. So like I say, you can have one server, and then you can have an instance of Windows 2008, you can have an instance of Ubuntu, you can have an instance of Unix, blah, 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 blah. You can have as many instances as the hardware will be able to cope with. Then with the hypervisors, we are dealing with two types of hypervisors. They're literally called type 1 and type 2. Type 1 is native or bare metal. The hypervisor gets installed directly onto the hardware. There's no middle layer, there's no operating system. You have the hardware, then you install the hypervisor, and then you install the instances of operating systems onto that hypervisor. With type 2 hosted hypervisors, this is where you have the computer, then you install an operating system, whatever operating system you want to install, then you install a hypervisor onto that operating system. It looks much like a normal application. Then you install the instance of the operating system that you want to use into the hypervisor that's installed on the operating system, which is installed on the hardware, and then you go about your day. There's a final version, when you're dealing with virtualization now, is you do have the hosted solutions. We have, Amazon Web Services, 1&1, GoDaddy, all these different companies have virtualization platforms you can use, and that's all their proprietary stuff. So when you're dealing with virtualization and you're dealing with hypervisors within your environment, so within your building, within your house, within your business, you're going to be dealing with type 1 or type 2 hypervisors. If you go out and you decide to do something virtual on Amazon Web Services or such, that's kind of their own little beast, and it works, however it works. I have no idea how it works. It just auto-magically works somehow. The main thing that you have to understand is the type 1 and the type 2 hypervisors. So let's talk about type 1 hypervisors. So when we're talking about type 1 hypervisors, we're talking about bare metal hypervisors. Again, what bare metal hypervisors mean is that you have the hardware, you install the hypervisor directly onto the hardware, and then you install instances of operating systems onto the hypervisor. So when you're looking at the hardware that you're going to be using type 1 hypervisors on, you're looking at real servers. So for me, this is one of the servers that I use for type 1 hypervisor virtualization. This is a real bad, nasty little 1U Xeon bugaboo server. So this server is something that will sit in a server rack. This is not the type of computer that is going to be sitting under your desk. If you've ever heard one of these things turned on, it's deafening. It sounds like a little jet engine underneath your desk. So when you're dealing with type 1 hypervisors, you're not going to generally be dealing with the types of computers that you would buy at Best Buy or at Walmart or such. When you're dealing with type 1 hypervisors, you're going to be dealing with real enterprise servers. The reason for this, we're gonna talk about in a minute. So, with these type 1 hypervisors, again, what you're going to have is you are going to have your physical server here. So this is going to be that 1U server that I just showed you. You then, onto that physical server, you are going to install the hypervisor. So this type 1 bare metal hypervisor, think of it as a very basic operating system. So just like you would install Mac OS X, or you would install Windows 7, or you would install Linux, you would install the hypervisor onto the hardware. So it's a pretty simple install process. Basically, you put in the CD, you hit next, 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 and then it gives you some information at the end. We're not going to go into this in depth and actually show you how to set this up. We will do that at a different class. Right now, I just want you to give you the concepts. Then, once you've installed the hypervisor, you can then install instances of operating systems onto the hypervisor that is on that physical hardware. So like I say, you can have Windows, 2008, Linux, Unix, etc., etc., etc. Basically, as long as the hardware can support it, you can continue to put instances of operating systems on there. You could have 50 instances or 100 instances. God help you, however much you want to put on there. Now, here's one of the big things. When you start using hypervisors, it's going to throw you for a loop. Kind of like the first time you use Linux. If you remember the first time you used Linux, you install it, and then you get a little blinking cursor, and then you don't know what the hell to do next. That is going to be what is going to happen with you the first time you install a Type 1 bare metal hypervisor. Because you're going to install that hypervisor onto your hardware, and then when it reboots, it's going to give you its IP address, and that's about it. Basically, you're looking at the equivalent of a little Linux graphics screen that's going to give you very, 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 very little information. It's going to give you its IP address, what kind of processor is on it, the RAM, and that's all it's going to have. And you're going to scratch your head. You're going to be like, what the hell? What do I do with this? Because you're just looking at a screen, and you're just getting a blinking cursor. Well, the reason for that is with a Type 1 hypervisor, you need something called a management console. So the management console is what actually manages the hypervisor. So you don't do very much of anything on the physical computer directly with that hypervisor. What happens is you sit at a computer like this. On the computer, you will have management software installed, and then using that management software, you will then manage this hypervisor. We'll get into this more when we actually do a practical class on the hypervisors, but basically what you need to understand is you are going to have a computer that will have the management software installed. Using that management software, you will connect to this hypervisor. That's why they give you the IP address of the computer. And then from there, you are able to install and manage these instances. So basically, I would go to the physical computer. So this computer, I would install the hypervisor on. I would then throw this into the rack. I would connect it to the network. I would make sure that this server gets the IP address. So the hypervisor will say whatever the IP address is, right? So once this is in the rack, once it has an IP address, I will then go to my normal desktop computer that has the management software installed, and then I will be able to configure the hypervisor from here. So I'll be able to install operating systems from here. I'll be able to do all the funky configurations. This is very important to understand. Like I say, when this server boots up, the screen you're going to get, again, it's going to tell you the computer has a Xeon processor, how much RAM it has, and a few other almost pointless things. There's very, very, very little you can do at the computer with the hypervisor installed. Most of the time, basically all you can do is like change a password and change the IP address. That's about it. So that is how you're going to be interacting with the hypervisor on the server. So through the management console. Why this happens in this way is because since the management is controlled by the management console, you can now have this management console make things automatically happen with servers with this type of hypervisor installed. So let's say you have a rack of physical servers, those one-use servers I showed you. Let's say, I'm not going to write them down. Let's say you have 20 in that rack, right? You then have the hypervisor installed on all 20 of those computers. Well, now, with the management console, you can move instances of operating systems between these physical servers, again, basically like copying and pasting. So if you have Windows 2008 server running on this hypervisor, on this server, you can simply move it to this server through the management console and it will just work. Basically, you just click, I want to move this instance from here to there, and it will just auto-magically happen. You can now move the instances of the operating system that easily. With the management software, you can also get a lot of cool other features. So when you're using servers, if you've been in an enterprise environment, you know that servers need different amounts of resources throughout the day. So if you have an Active Directory server, an Active Directory server is what allows you to authenticate or log on to a Windows network. Now you need to hit that server a lot, or your employees will need to hammer that server a lot. Let's say, in the morning or after lunch is over, etc. There's going to be certain times of the day, and that server is going to need a lot of resources. At other times of the day, it's not going to need so many resources. Well, what this management software can do is it can automatically move instances of operating systems between physical servers based on their current resource needs. So let's say right now we have these 3 instances of operating systems running on this hypervisor. None of them is being used very much, so none of them need very many resources. They're all just trucking along, doing fine. Well, all of a sudden, a lot of people start logging into the Windows 2008 server. It starts needing a lot of resources. It starts needing more resources than this physical server can handle. Well, the management software will then automatically move this Windows 2008 instance to whatever server, physical server, has enough resources for it to run properly. So it can just migrate literally that easily, that automatically. Why this is important in the enterprise world is electricity bills get very high. This one little server down here can probably cost $100 or $200 a year in electricity. It pulls a lot of electricity. So obviously, if you have hundreds or thousands of servers, that can be a very big power bill. Well, if you can automatically consolidate servers or send them out to different pieces of hardware based on the requirements, you can have your hardware be turned off most of the time and only be turned on when it's actually used. That's one of the cool things with the management software and the new physical server hardware that's out there, is this management software can actually turn these servers on and off as needed. Not simply moving the instance, but actually turn them on. So this server can be off. The management console or the management software can decide it needs to use it. It can turn it on. It can move the instance, and that's how easy it goes. Also with the management software, it can do things for fault tolerance. So let's say you have this server, the instance of the server running on this hypervisor. Well, with the management software, if the physical hardware fails that's running all of this, the management software can automatically migrate these instances literally so quickly that you don't even realize that the physical hardware failed. So imagine that, especially in the enterprise world. If the hardware for a server crashes, it's no big deal. All the instances of the operating systems were automatically moved. They're all up and running. Your users never saw any downtime. They never even saw a blip. And so now you can fix this hardware whenever you get around to it. That's one of the things that makes these Type 1 hypervisors so cool. And again, all these powerful features are probably not something you're going to be using in your house or you need to use in your house, but in the enterprise world, they're really, really, really good. Now, when you're doing this, one thing to think about with when you're deciding the hardware and such that you're going to use is that some of these Type 1 hypervisors allow you to do something called over-allocation. So what over-allocation means is if this physical server here only has, let's say, 16 gigs of RAM, right? And you want to put multiple instances of operating systems onto that hypervisor. So you want to put Windows and Linux and Unix, right? Now what you can do is you can actually give these different instances of the operating systems more total RAM than the computer has. So you can say this Windows 2008 server can have up to 12 gigs of RAM, this Linux server can have up to 10 gigs of RAM, and this Unix server can have up to 8 gigs of RAM. If you add all this up, it comes to 30 gigs of RAM. Well, there's only 16 gigs of RAM on here. What over allocation allows to happen is each one of the instances of these servers thinks they have this much RAM, but the server, the hypervisor, only gives them the RAM that they actually need. So again, remember, throughout the day, your server is going to need more or less resources. So at the high point, your Windows 2008 Active Directory server might need all 12 gigs of RAM. 1% of the day it might need all that RAM. The rest of the day it only needs 2 gigs. Well, what can happen is when that Windows 2008 server needs the 12 gigs of RAM, the hypervisor can give it all that RAM, while your other servers don't need it. They're just sitting there. One's a file server and one's a web server. They're fine with 2 gigs of RAM each. Well, once the time has passed where this Windows 2008 server needs all that RAM, the hypervisor can take it back, but the Windows server doesn't see it. The Windows server still thinks it has 12 gigs of RAM. But the hypervisor can take it back and give it to, let's say, the Linux server or the Unix server if it needs it. So in the morning, the Windows server needs 12 gigs of RAM, so it uses all 12 gigs of RAM, and the Linux web server doesn't need it. Well then, an hour later, the Windows server doesn't need as much RAM. The Linux server, let's say it's getting hammered as a website, it needs all the RAM it can get. So then the hypervisor now gives that Linux server the RAM it needs. That is something called over allocation, and if you're looking to purchase a hypervisor or use a Type 1 hypervisor, it is something that you should look for. Some of the old hypervisors or some hypervisors you may run into, they only allow you to split up the RAM statically. So you can give, if you give the Windows 2008 server 12 gigs of RAM, then you've only got 4 left to split between those two. So you could give that one 2, and that one 2, or this one 3, this one 1. Basically, however much RAM you give to these instances of servers, those all have to equal the total amount of RAM that is on the physical server. So that's static allocation. With over allocation or dynamic allocation, the total doesn't have to equal the exact amount here, because with the over allocation, the hypervisor can move the RAM as need be. Now, when you're dealing with these hypervisors, when I'm talking about it, there are a lot of different hypervisors out there. There's a lot of different vendors that sell virtualizations, Type 1 hypervisors. There's Citrix, there's VMware, there used to be Virtual Iron that got purchased by Oracle. I'm not sure what they're doing anymore. There's Microsoft, etc. Now, when you go out there, what you're going to find is that the hypervisor, generally, as I always say, the hypervisor is free. Yes, surprisingly enough, either from VMware or Citrix, whatever company. Most of these hypervisors, I think almost all of these hypervisors, are based on something called Xen. X-E-N. So it's called the Xen hypervisor. This was created years ago on the Linux platform. It worked so well, basically everybody took it. It was open source, it was free, it worked so well, again, like I say, people decided we'll just go with that versus creating our own. So when you're dealing with a hypervisor, you can get the hypervisor for free. Well, again, whether you use VMware, whether you use Citrix, whoever you're using, you can normally get the hypervisor for free. Where they get you is that the management software, what does all this, flipping operating system instances around and all that fault tolerance and stuff, that is what they charge you for. So if you go out there again to Citrix or VMware for a Type 1 hypervisor, you should be able to install a free hypervisor and free basic management software that you can use both personally and commercially. So last time I looked, VMware server hypervisor and Citrix, you could use for free in a commercial environment. If you work for Microsoft, you could install it for free. Well, what they do is they only give you limited features with the management. So you can install operating systems instances on the hypervisor. You can do some basic management tasks. That is it. If you want to get the really cool super features where you can move instances of operating systems around, in the blink of an eye, that will cost you money. And it will cost you a lot of money. So last time I looked, like with VMware, the basic level of their management software that was really worth a damn, they had some stuff that was cheaper. But the stuff that started actually having all the really cool features started at about $3,000. So the last time I looked, it was $3,000 for the management software, and it went up from there. 10, 20, $100,000, depending on what you want to do. This is just something that you should keep in mind if you're going to be trying to use a Type 1 hypervisor. Again, what is really cool with it is almost all the companies, again, it's up to you to look at the license, but last time I looked at the licenses, it was free for commercial use. So you could install the hypervisor and you could install a basic management console absolutely free. The thing is, if you wanted that really cool functionality, that's where you had to pay for this super expensive management software. That's where it all, like I said, gets expensive. So again, Type 1 hypervisors are bare metal. You install the hypervisor directly on to the hardware. You then install instances of operating systems onto the hypervisor. But as I say, you don't do that directly on the hypervisor or on the physical computer. You use a piece of management software installed on a different computer to interact with the hypervisor and do all the management, install the operating systems, configure whatever settings, etc. We talked about the overallocation. So what overallocation means is if your hypervisor allows it, you can provide more RAM than the server physically has. So with this, we have one computer that has 12 gigs of RAM, one that has 10, one that has 8, that comes with 30 gigs of RAM. The physical server only has 16 gigs of RAM. Basically what you're betting on or what you're planning is that at any one time you will only ever be using 16 gigs of RAM. So sometimes your Windows 2008 server can have 12 gigs of RAM, and sometimes your Unix server needs 8 gigs of RAM. The main thing is that at any one time, you only have, not all the instances together aren't going to be using more than 16 gigs of RAM. And finally, like I say, when you're going to be using these hypervisors and management software, again, free, even for the commercial world, even if you work at Microsoft, you can install it and run some Microsoft website off of it, completely legit, legally, at least last time I looked. The issue is, if you want the really cool features, you're going to have to pay a stupid, foolish amount of money. That's how it goes. So we talked about the Type 1 hypervisors. So these are bare metal hypervisors. So now we need to talk about Type 2 hypervisors, or what are called hosted hypervisors. Hosted hypervisors are hypervisors that are installed onto the operating system itself. So whether you have Mac OS X, Linux, Windows 7, etc. Basically, you have the physical computer, you install the operating system onto the physical computer, you then install the hypervisor onto the operating system, and then you install the instance of the operating system onto that hypervisor. So before, you had the server, and then you had the hypervisor. Basically now, you have the server, then you have an operating system, then you have a hypervisor, then you have the instance. What makes this nice, what makes this easy, and why you all probably would want to do this versus the Type 1 hypervisor is you don't need this management software in order to configure and play with the instance of the operating system that is on your computer. Basically, the instance of the operating system on a Type 2 hypervisor literally opens up in a window, just like any application, and then you can just use it. You can right click, you can left click, you can write documents, etc. You don't need management software in order to be able to play with it. So for most people, this is the type of virtualization that they're going to be using. Even in the corporate world, a lot of people use Type 2 hosted hypervisors. Like I say, just because it's easy. You know, if you're not worried about consolidating 100 servers into one box, you know, you just want like 2 or 3 or 4 or 5 servers running on one box, it may be a lot easier to use a Type 2 hosted hypervisor because you can just turn on the screen for the box, you got a little mouse, you can do whatever you need to do, and then you can walk away from it. You don't need this management software. Now, the nice part, again, with Type 2 hosted virtualization is many of the products are free. So from Microsoft, there's Virtual PC. From Oracle, it used to be Sun Microsystems. There is VirtualBox. There are other options out there. These Type 2 hypervisors are generally free to use. Sometimes if you want to use the more advanced features, you have to pay a little bit of money, but you know that's how it always goes. A couple of the warnings that I will give you if you decide to start using a Type 2 hypervisor is be careful of the resource allocation that you give your instances of operating systems. So if you give a server that you're installing onto your computer, let's say 4 gigs of RAM for the instance, it will automatically take all 4 gigs of RAM even if that server is not using it right then and there. So we talked about with Type 1 hypervisors where you can do the over allocation. That's not really how it works with these Type 2 hypervisors. For the most part, if you give an instance a certain amount of RAM or a certain hard drive space, the virtualization hypervisor will automatically take that from the host computer for the instance. Why this can be a problem is because you can literally take so many resources for your virtualized instances that you can end up crashing the host computer. So the host computer, let's say it needs 2 gigs of RAM simply to run, you know, if you're using Windows or something. Well, if you have 5 gigs of RAM, and then you give 3 gigs to some server, and then you give another gig to another server, well, if those 2 servers are turned on at the same time, 4 gigs of RAM will now be taken for those instances. Your hosted computer now only has 1 gig of RAM left to do what it needs to do, and then it just crashes. It all goes bad. So just be careful about this. Whatever resources you give to the instances of the operating system, when you turn them on, the computer will automatically take those resources. The other warning that I will give you is be careful of networking if you are going to be using the host computer for other things. So let's say you create a web server in an instance, and you create an FTP server in an instance, you create an Active Directory server in an instance, and all those need to use the network. Well, if you open up Outlook, or if you're browsing the web on the host computer operating system, sometimes that network traffic can all get a little wiggly, and it doesn't work properly. So I've seen this in the past where we've created instances of operating systems and turned them on a host computer, and then email just stops working. Web browser works fine, file transfer works fine, but Outlook just stops receiving email. This can be one of the issues that comes about when you're using these Type 2 hypervisors. So if you have the instances turned on and you're using the host computer doing stuff, things may get a little weird. The other warning that I will give you is with all of this Type 2 virtualization software, Virtual PC, VirtualBox, etc., they almost always have operating system add-ons. This is software that you can automatically install into the operating system that's installed on a hypervisor. This will make the operating system instance run much better. I don't know why. It's really weird that it's not automatically installed, but if you don't install these add-ons, you can have some problems for some reason. But yeah, that's basically what Type 2 hypervisors are, and these are probably what you're going to be using. We do have a class on Type 2 hypervisors, introduction or VirtualBox. We have VirtualBox class. You can go do a search for it. We have one, which will show you how all this works. But basically with the Type 2 hypervisors, again, you have the hardware, then you have a normal operating system, Windows 7, OS X, Linux, Unix, whatever you're using. Then you have the hypervisor, then you have the instances of the operating system, and that allows you to run multiple instances of operating systems on one computer. You can do this for, testing out projects. If you're creating new software, you can test it out on different operating systems. If you're a web developer, this means on one computer, you could have a Mac OS X computer and a Windows 7 and a Linux, and you can look at the website you're designing. You guys, if you're going out to test for these Microsoft tests, you can buy a really, really, really powerful desktop computer with, let's say, 30 gigs of RAM, and then you can actually create an entire virtual network on that one computer. So you could create a 2008 Active Directory server, a 2008 IIS server, and 4 client computers, and a Linux computer, and then you can all try to network them and do all the weird projects that Microsoft wants you to be able to do. You can do all of that. So those are some of the reasons that you would use a Type 2 hosted hypervisor in the real world. Now at this point you may be thinking, well, all this virtualization technology is really cool, this is great. But the problem is I've got 50 servers up and running, and they're already up and running. And although virtualization sounds great, I don't want to have to migrate each one of those servers to a new virtual server. They'll just take forever. Well, one of the nice parts now is there are a lot of ways to convert old operating systems that are installed on the hardware to the virtualized environment. So depending on what virtualization product you're using, they have conversion tools. Basically all you do, like normally, you copy the conversion tool onto a CD, you boot the CD on the server you want to turn into a virtual computer. It boots up, it will then package the entire operating system and everything into a virtualized instance, and then you can simply put that onto a server that has a hypervisor. So whether you copy it onto a hard disk drive or you do it over the network, etc. Basically what the software does is it images the computer into a virtual hard drive format, whatever hard drive format your hypervisor uses. This is something to be careful about. The different companies do have different virtual hard drive formats, so make sure whatever virtual hard drives you have, compatible, etc. So basically, like if you decide to go with VMware for your virtualized solution, you can install the hypervisor onto one piece of hardware. You then take this CD over to a server that you want to virtualize. You boot the server off the CD. It turns that server into a virtual hard drive. You can then move that virtual hard drive over to the hypervisor, and now that's all you have to do for the migration process. There's no copying and pasting, there's no migrating Active Directory and all that crap. Basically, you have a normal server where the operating system is installed on the hardware. You run this conversion software. It basically is able to package up, to ball up that operating system into a virtual hard drive, and then you can move that virtual hard drive over to your hypervisor. Another nice thing nowadays is many of the backup solutions actually back up into virtual hard drives. So with Windows and with something called Acronis, different types of backup software, when they do their backup routine, the format that they back up into is a virtual hard drive. So if you have a computer and you have this backup software installed, you can simply back up to a virtual hard drive and then move that virtual hard drive over to the hypervisor that you want to use. It really, really, really is that simple. If you want to play around, let's say you want to use Linux or Unix, and you want to do very specific tasks, one of the nice things they have with the virtualization now is something called appliances. So you can go to VMware or Citrix, and they will have a list of appliances. These appliances, these virtual appliances, are basically servers that have already been configured for you. So if you want an Ubuntu web server and you don't want to have to go through the whole install routine, you can download an Ubuntu web server appliance. And it's it's already been set up. So it's a little virtual hard drive you can download with all the configurations. Basically, all you do is you put that onto the hypervisor. The hypervisor turns it on, and then away you go. You don't have to go through with the installation process and the configuration process, etc. With these appliances, there's a lot of cool things. Not only can you have servers, but you can have networking equipment. So you can have virtual routers, you can have virtual switches, etc. This gets really complicated and gets way beyond the introductory class. But if you're worried about security in the real world, routers and firewalls, networking equipment provide a layer of security for servers when network communication happens. Well, you can have the equivalent, basically virtual routers, virtual firewalls on your hypervisor. Then you can have your virtual instances of the operating systems do their networking through those virtual pieces of networking equipment. And this just provides a layer of security. So basically, without having to buy very expensive Cisco equipment, you can download these virtual appliances and come up with a really insane, complicated networking scheme. You can. At this point, I wouldn't do it if I were you, but you can. This is something to think about. So the big thing is, if you're thinking about migrating from how we've been doing it, where the operating system is installed on the hardware, to virtualization, you don't have to go through the nasty old migration process. You don't. Basically, all you do is you use the conversion software. It will convert the old server into a virtual instance. You then move the virtual instance to the hypervisor, and then away you go. Again, one of the really nice things with modern backup software is they will back up to a virtual hard drive format. So if the physical server fails, you can simply move that virtual hard drive over to a hypervisor, and the server is back up and running that quick. Then the final thing, like I say, is these appliances you should look at, you should play with, because people go out, they configure servers to do very, 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 very specific things, and then instead of you having to install the operating system and do all the configurations, you can just download that appliance, basically turn it on, and away you go. Really, I mean, even though it doesn't take too long to set up an Ubuntu server, it takes 30 minutes to an hour, let's say. If you download and set up one of these appliances, you can literally be up and running in 5 minutes. That's pretty quick. So final thoughts for this introduction to virtualization class. Virtualization is a great new tool. It is very, 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 very useful, and if you've been in the IT field for a while, it is just a godsend. It really is great. Basically, just remember, all virtualization does is it separates the operating system from the underlying hardware. So you can move it around just like a picture, just like a movie file, etc. Virtualization is not cloud computing. Virtualization is a component of cloud computing. Cloud computing is something much larger. Virtualization separates the operating system from the hardware. Cloud computing separates the application from the hardware. If you don't understand what that means, well, just keep doing these classes and you'll understand later. Basically, it is a very big distinction. It doesn't sound like a very big distinction, but at the end of the day, it's a huge, mammoth distinction. One of the things I will give you the warning about, remember, we are professionals here. This is not simply about setting up servers, etc. Licensing. I always talk about licensing because in the real world, if you're going to be management level, licensing can be evil. So be careful when you're going out to purchase hypervisors, when you're going out to purchase virtualization software. Their licensing can be a nightmare. So depending on what hypervisor or management software you're going to be using, let's say if you're using the type 1 hypervisors, the cost can get bad really quick. So sometimes with licensing, this is something I ran into the real world. So sometimes with licensing, let's say for the hypervisor and the management software, sometimes each license covers one physical box. So you have one server and you need one license. Oh, that seems pretty simple. Yeah, that is pretty simple. Well then, sometimes, since we're dealing with servers here, we're dealing with real servers many times can support multiple processors. So you could have a 2-socket motherboard or a 4-socket motherboard or an 8-socket motherboard. So you can actually have up to 8 processors on the motherboard. Well, many times the virtualization software is licensed per socket. So if you have 2 processors on one physical server, then you need to purchase 2 licenses. Ooh, okay, that can get a little painful. But hey, maybe that works. If you've got 2 processors, that's a pretty powerful server. Well, here's where it can get dumb, ridiculously quick. Sometimes you have to pay licenses per core. So this is a Xeon quad-core processor. If I used some of the enterprise hypervisors out there, I would have to pay a license per core, even though it's one chip. So one processor in the server has 4 cores, so you have to pay for 4 licenses. I wish that was a joke. So this is something you have to be exceedingly, ridiculously careful about in the virtualization environment. Licenses. You think Microsoft licensing is bad? Virtualization licensing makes Microsoft licensing look like a joke. So make sure you know what you're buying. Again, if you have 2 processors in one physical server, you may have 8 cores or 16 cores, and so now $1,000 for a license, maybe $16,000. That's a lot of money, so be very exceedingly careful about the license. Read the licenses. Again, the nice part with most of this virtualization software is when you're playing around, or even if you're doing simple things in the commercial world, it's absolutely 100% free. You can use it. Like I say, Microsoft can use it. Once you start getting into these more powerful things that the virtualization software can do, like I say, you can go from free to $16,000 in the blink of an eye. And if you don't know what you're doing, it can be really, really, really bad. So as we talked about, type 1 hypervisors or bare metal hypervisors, this is where you have the hardware, you install the hypervisor, then you install instances of the operating system onto the hypervisor. Now remember with this, in order to manage that hypervisor, you need a management computer. So it's just a normal computer, like when I do it, I just have a normal Windows 7 desktop. I install the client software onto that Windows 7 desktop, and then that client software communicates with the hypervisor, and I'm able to do all the communication stuff. Again, like I said, the first time I booted up a real bare metal hypervisor, all you get, I think I did VMware server. You get a yellow box. It tells you the IP address. It tells you have a Xeon processor and how much RAM you have. And then you scratch your head and do, what the hell do I do next? Well, what you do next is you go over to your client computer and configure everything. The nice part with this is that, again, you can move instances of operating systems between different pieces of physical hardware fairly easily. If you're willing to pay the ridiculous amounts of money, like I say with VMware, it starts at about $3,000, you can do all this fancy auto-magical stuff. So you can have the management software where it turns on servers as you need them turned on. You can have it so it automatically moves instances of operating systems if a piece of physical hardware fails. So even in a small office environment, you could have 3 physical servers that are connected for virtualization. If one fails, all those instances of the operating systems automatically migrate to the other server. So there's no downtime. So this, it's expensive, but it can be very useful. The main thing to remember, though, is you're going to pay a lot of money for that. As we talked about, the hypervisor and the basic management software is almost always free. Again, it's all based off the Xen XEN that was created, 10 years or so ago. Xen is robust, stable. You can't do much better than it, so nobody really has tried. Almost everything is based on it. Then we talked about the Type 2 hypervisors. Type 2, again, we have a class on VirtualBox for virtualization. All this is you have a normal computer, Mac, Windows 7, Linux, whatever. You install the virtualization software onto that operating system. So you install Virtual PC, VirtualBox, VMware Fusion, Parallels, etc. You then install the instance of the operating system onto that virtualization software. So this is very useful. Again, in the Mac world, I have a MacBook Air. When I need to use a piece of Windows software, I can literally open up Windows within a window on the Mac, use Windows all I want, and then shut it down when I don't need it anymore. The things that you have to be careful about if you're going to be doing type 2 hosted virtualization is, again, remember, with allocation, if you give too many resources to your virtualized computers, your host computer may not have enough resources to keep running, and you may end up actually crashing your host computer. Remember, if you give resources to the virtual computers in a type 2 environment, the computer automatically gives those resources away, and then your hosted computer can't access them anymore. The other thing to be careful about is with networking. If you have virtual servers and they're using networking, and you're on your hosted computer, and your hosted computer is doing networking, you can have issues. The biggest one I saw in the real world was when we had web servers running in the virtualized environment on my computer. If I open up Outlook, sometimes you just want to get email. As soon as you shut off all the virtualization software, you got email just fine. You know, I'm not going to tell you why it happens, it just happens. Finally, we talked about converting normal servers to virtual servers. So if you have servers, you know, they've been running 5 years, 10 years, 20 years, you don't want to do a migration, normal migration. You can convert those servers to virtual servers and house them into a hypervisor. So this is really big right now. Remember, you know, when I started playing around with computers and started in the professional world, it was back with Windows 95 and Windows NT. Some people still have NT servers running. Sometimes those NT servers are still doing mission critical work. The problem is none of the hardware that those NT servers are running on is sold anymore. And if that NT server crashes for any reason, the client is screwed. I mean, it really, really is god awful bad. So what you can do is you can convert that NT server into a virtual server, and you can put it on the hypervisor. Now it's still old and it's still archaic, and they still do need to upgrade, but they're no longer risking the death of their entire business. You know what I'm saying? There's a difference between obsolete and something crashing and dying and burning and taking everyone with it. So this is something with virtualization that you should think about for your clients. So you go in, they have old NT servers or 2000 servers. Basically, you can virtualize those, put them onto hypervisors, and now they're stable. They're obsolete, but they're stable, and hey, and you made a few bucks off of it. So this was a class, Introduction to Virtualization. Virtualization, you know, it's not horribly complicated to do. We do have a class, you know, VirtualBox for virtualization. I am going to do a class with one of the Type 1 hypervisors, show you how it's to work. Again, this is relatively simple technology. At this point in time, it is completely 100% stable. I have seen virtualization for 10 years now. It's been stable, basically, for like 10 years now. So this isn't cutting edge. This isn't bleeding edge. This isn't any of that. Basically, you just have to figure out how you want to configure you have to sit down, you have to figure what you want to do, figure out what you want to do. Then you have to figure out what product you want to buy. Then you have to configure the product. And then you install everything, and then you go home. It's really that simple. You know, a lot of people get worried about virtualization. They think it's, oh, what if everything blows up? We're not there anymore. Things are much more stable now, robust, etc. This is old technology. This is paperclip technology. Basically, it works. As long as you configure it properly, it works. It's not that complicated, etc., etc., etc. So, as you know, I'm Eli the Computer Guy over here for EliTheComputerGuy.com and EverymanIT.com. Again, this class was Introduction to Virtualization. I enjoyed teaching it and look forward to seeing you at the next one.